So here we'll talk about set operations. So we'll start with the intersection. If A and B are sets, the intersection, which is denoted by this thing that looks like an upside down U, is the set of all elements that are in both A and B. If we look at the Venn diagram, we can see that it's the elements they have in common. And this works for both finite and infinite sets. So for example, if A is the set of all integer multiples of 2, and B is the set of all integer multiples of 3, then A intersect B would be the things they have in common, which would be all the integer multiples of 6. We also have the union. So if A and B are sets, the union, which is denoted by this thing that looks like a U, is the set of all elements that are elements of either A or B or both. It's like taking all of A and then adding in B. This can also apply to a set of infinite sets. So once again, A is the integer multiples of 2 and B is the integer multiples of 3. So A union B is the integer multiples of either 2 or 3. So you have 2, 3, 4, 6, 8, 9, 10, 12, etc. So here's an example. We want to find A intersect B and A union B. So for A intersect B, we want to know what they have in common, which we can see is both 2 and 4. For the union, we take everything in set A and then add in the 6, 8, and 10 from set B. The difference of sets, so we say the difference of A and B, which is denoted by this A minus B, is the set of all elements that are elements of A, but not of B. It's like looking at A and then taking out what they share, what they have in common. So for example, let's find A minus B. So we know that these two groups share 2 and 4. So A minus B will be 1, 3, and 5, since we'll exclude both 2 and 4. For B minus A, we exclude the 2 and the 4 to get 6, 8, and 10. If A is a set and U is the universal set, the complement of A is denoted by A bar. It's a set of all elements that are elements of U but not of A. It's like saying everything that's not A. So for example, we want to find A bar. We know A is 1, 2, 3, 4, 5. U, our universal set, is everything up to 10. So A bar would be 6, 7, 8, 9, 10. For B bar, we would want the odd numbers since B consists of all of the even numbers. Our final operation is the product of sets. So if A and B are sets, the product, which is denoted A cross B, is a set of all elements of the form AB, where little a is in big A, little b is in big B. So this is the set of all ordered pairs. So for example, if A is 1, 2, 3 and B is AB, we just make the ordered pairs. The main thing is the first element should be in A and the second element should be in B. So we have 1A and 1B, 2A and 2B, and then 3A and 3B.